Okay, so guys, the people who have already joined, we'll be using menti.com for interaction, and so you can open menti.com with the code 1775882, and you can use your mobile browser or your computer browser for the same. And please use the chat box for informing me if you have any questions, and if you feel that some screen is not being shared at some point of time or I'm not audible, just feel free to post it on chat. And I'll repeat again, you can go to menti.com and use this code 1775882 to this. The website name is menti.com. I think it's shared on the screen. That is www.menti.com, and you can use the code 1775882. I'll just share the same link and code in the chat box. Okay, once you go to the link, please hit the thumbs up button so that I can see who all have joined. But it will help me to know about you, and we'll have some interaction during the session.
Actually, it is saying the quiz is not open.
So okay, the link is not working. You
No,
mean?
no, link is working, but it is saying the quiz is not open. Please wait for the presenter to activate it.
Okay, let me check at my end.
Not fine.
Okay, so I guess there was some glitch from Menti itself. Okay, thank you for telling me it's not working. Okay, so I can see six people have already joined and they are continuously giving thumbs up. So it's nice. Okay, so again, it's a question. So Swati, now you can try and the quiz is active now. So let's start. So first, I want to know from you all that what do you know about microservices? So you can say it in one or two words. What microservices or what are microservices according to you? And then we'll proceed further. So you can use menti.com for the same. And people who have not joined, they can also type in the chat box. It's okay. Small services, design pattern, architecture. Yeah, correct. Piece of isolated work. Okay. Deploy small services, correct. Small services, correct. Loosely coupled, yes. Build up of small services, yes, that's correct. Okay, so I think you have all answered correct, and you have idea about somewhat idea about microservices. So I'm happy to know that. Okay, so let me know about you guys. So you can share your experience in the following things like microservices and programming and containers or CAS or PaaS maybe. So people having more than 10 experience, they can mark it as 10 itself. Okay, so I can see that there are programmers in attending this webinar, and the average experience is zero point 0.4 in microservices. Okay, and there are people who have around 2 years of experience in microservices. People having around 8 years of experience in programming languages. Okay, that's good. Okay, so I'll adapt my content according to you. So I'll focus more on microservices and okay, from basics. Okay, thank you guys. So do not close this menti.com. We will use this in future as well during the session. And let's continue on the presentation now. Okay, so before moving to the presentation, let me introduce myself. I am Saurabh and I have overall 10 plus years of experience and I'm working as an architect in telecom domain. And before this, I also worked for e-commerce domain as well. Okay, so let's talk about the evolution of microservices. So decades ago, there was monolith, and what monolith is, there was a single deployable unit which contained all the things, user interface, business logic, as well as the data. And that single unit was deployed on bare metal machines, and they used to consume a lot of hardware resources, CPU and RAM and storage, everything. And when the applications went on growing, and it was very difficult to manage the development of such kind of architecture because synchronization between the large team and that too the boundaries were not defined between user interface and business logic, so the code was kind of spaghetti code and it was difficult to understand, difficult to manage. So the next architecture evolved was multi-tier, where there was a clear separation between the front end, back end, and the data layer. Here, the deployment was done, and there was a clear separation in terms of deployment as well. But still, the deployment was done either on bare metal machines or the virtual machines. And again, when the application went on growing due to the demand, again there was a it was difficult to manage the backend, especially the backend part, because it would keep on growing and teams were growing. It's very difficult to synchronize the task and the work across the team. So next architecture was evolving, and then we moved to service-oriented architecture, where the backend again got segregated, and now the architecture was capable of using more than one database at least, and people moved to NoSQL databases as well. And the boundaries for the services were clearly defined. Each service had the specific role or a specific functionality, but all the communication between the services was happening with enterprise service bus. And this enterprise service bus was responsible for other functionalities as well, like managing the transaction across the services or exchanging the data between them. So somehow this was the single point where a lot of functionalities were involved, and somehow this became the bottleneck as well, because this turned into the single point of failure. If this ESB gets failed, the whole system will go down. So one of the problems was this, and second problem was around sharing the databases. Since services got divided, but still they were sharing the database, and if 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 there was a change from any of the service in the schema, and the other services were also getting impacted. And then of course some of the domains were continuously growing, and again it was difficult to manage such kind of architecture. And currently we evolved as microservices architecture. Here there is a clear separation between the services. There is no single point failure kind of thing which can become a bottleneck, because each and every service is scalable. You can scale up to n number of instances. The database got separated because generally in microservices we use database per service, so no two services share the database, but yes, any of the service can use more than one database. Okay, so this was about the evolution, how we moved from monolith to microservices. Now let's talk about some misconceptions about microservices, and we'll see what are the correct meaning of microservices. A lot of people think like microservices means just small services. It's not wrong sentence, but it's partially correct. The real question should be how small and how they will interact. Are we So once we start creating the small services, then we should ask ourselves: Are we creating nano services or are we creating macro services? So there has to be very clear specification how small we are going. Okay, and the second thing, of course, okay, we got the system or application is split into services, but how they will interact with each other. Okay. Second misconception is microservices and API are same thing. That is not the case. API is one of the way for communication between the services. Okay. Third one, microservices completely eliminate complexity, but that is not the case. Microservices divide your complex problem into small pieces, but also it adds a lot of complexities with that. So since we are moving into distributed system, we are dividing our application into services. So that leads to some problems like resiliency and data consistency. So we'll talk about resiliency in next slide as well, but it's more of reliability because one of your service can lead to the uh, complete application failure. Okay. Okay, shifting from monolith to microservices easy. Uh, it's not easy because the we have to define some bounded contexts using the domain-driven design. And domain-driven design it's a large process. It's not easy where technical people along with the functional architects and your product owners all of are involving a lot of exchanges happen and they come to a common vocabulary so that they can exchange the functionalities or the problems with each other, and then the functionally the loose coupling using the I mean the functionally the services are segregated so that they are loosely coupled, and then somehow they are implemented technically as well. So it's not very easy, but not impossible as well. And this is the Java developers, and a lot of Java developers believe that using Spring Boot and Spring Cloud solves every problem, and we are into microservices. Uh, yes, it's a very good framework for Java, but it's a to start, I guess. But it's not the end because it does not implement all the microservices patterns. It implements I guess 40 to 45% patterns, but not all. So there are some patterns which we need to develop from our side. We can't rely on frameworks because they are not mature enough to implement such kind of patterns or functionalities. Okay, so anytime if you feel any question is there, please feel free to post in the chat. I'll answer maybe at the end of the slide or Maybe whenever I see the chat, I'll definitely answer your questions. Okay. Okay. So we talked a lot about it, but then what are microservices? Of course, it's not a framework. It's not an application. It's not in design. It's a design, but it's an architectural style actually, which helps us to structure our application into number of services, and those services should have some adjectives, or I would say some qualities, like these services should be highly maintainable and testable individually. We should not involve any other service while testing the one of the service. Functionally, these they should be loosely coupled. Okay. uh, each service should can be deployed individually or independently, because if let's say if we want to deploy any service one, that should not rely on service two to be deployed first, because they should be loosely coupled. And okay, they should each service should focus on the business capabilities. So technically it means they should follow some single responsibility principle, and each service should be managed by small teams. So nowadays we are moving into agile phase, and agile team should not be more than 10 to or 8 to 11 or 8 to 10 people. So each service should be maintained by small team. So here we can see a generic example of e-commerce domain, or and you can assume in any of other domain as well. But it's a very easy to get understand by all the people. So your complete e-commerce domain can be divided into a number of different services. These are not the exact services I would call, because uh, the real implementation will have a lot many services. This is just the high level segregation we have done. So it can be divided into catalog service, where which is responsible for searching your products. Because if we take an example of Amazon or so, most of the time we keep on searching rather than buying the product. So a lot of people are actually searching the products or exploring the products. So definitely the more number of instances are required by e-commerce domain to deploy that kind of functionality. Of course, a few of them also add something to the cart. So maybe a lesser number of instances are required than, of course, searching on a catalog. So cart, there can be a cart service, which in which you can add some products and can buy later or at the same point of time. A lot of people, okay, add to the cart, but still very few of them actually buy your product. So there is a payment service which is used while buying your product. So even lesser number of instances are required. So using microservices, there is no need that you need to scale the complete application, wherein let's say your when we were on monolithic, let's say it uses maybe 16 GB of RAM or 8 core CPUs. Then you don't need to replicate all of the hardware again and again, because the catalog is the thing which is needs to be have more instances. But at the same time, there can be some other services like maybe payment or other services which can have lesser number of instances. So that by this approach we will be saving our hardware resources as well. Okay. Okay, so we talked about a lot of qualities what the services should have. So they are achieved by some of the patterns. Okay, so they are called microservice patterns. So there is a listing here. You can see decomposition pattern, communication pattern, resiliency pattern. So I'll talk about these patterns one by one. But we cannot go into the details of every pattern, because each pattern, I guess, will take more than 3 to 5 days to cover each pattern. So we'll go in detail for two of the patterns, but I'll give you the generic overview of all the patterns. Okay. So decomposition pattern describes how you should split your monolithic application into microservices. Okay, so it describes all the approaches how we should go ahead with that. Second one is communication pattern. It describes how the services should interact with each other. It defines whether the communication should be synchronous or communication should be asynchronous. You can use REST APIs for synchronous communication. You can use messaging queues for asynchronous communication. So it talks more about that. The third one is the resiliency pattern. It talks about the stability of the system because let's take an example wherein card service will definitely use the payment service. Okay, and let's say at some point of time your payment service is down and there are lot many requests coming from card service to payment service and which will block all your threads because they will be waiting to get a response from your payment service. So somehow at after some point of time your card service will also go down because there's no response and a lot of threads will be waiting for that response, and certainly your card service will go down, and let's say catalog service will definitely need your card service, and certainly this cascade failure will make your complete system go down. So we need to take care using resilience patterns, and there is circuit breaker pattern which is used mostly for this case. Now it's a service discovery pattern. So this pattern describes or talks about how we will explore the new instances coming into the cluster, because I said like there can be number of instances for different services, and there can be according to the need they can scale up or scale down as well. So every time whenever there will be huge demand for your application, maybe at the time of some sale or something, so you will need a lot of instances for your catalog, and at runtime the instances should be deployed, and since they are getting deployed at runtime, so they will be allocated with some dynamic IPs, and so that has to be discovered because anyways you need to send a request to them, right? So this pattern is used, and we'll talk in detail in this seminar about this pattern. Transaction messaging pattern, it's more of how you will manage the transaction using the messaging queue. So let's say if some service by mistake push one of your notification more than once, so the consumer service should be intelligent enough to handle that. So some how your idempotent behavior will be working while consuming the messages. So it talks about that. Okay, so data consistency pattern is all about since you are now distributed in nature and using different databases, each service is using different databases, and now the modern databases like NoSQL databases do not support two-phase commit as well. So it's very difficult to manage your consistency while operating here. So you can use a saga pattern using choreography or orchestration. So this data consistency pattern is more about that. Let's go to the querying pattern. So it's since we have again the situation is same, we are distributed in nature, and let's say you need to query some data which is present in different services, maybe four or five or maybe 10 or 100. So it will be very difficult to query data from each service, right? So this pattern mostly talks about querying, and a lot of patterns like CQRS and API composition are part of this pattern. Next is external API pattern. So this external API pattern is describes like if there is some client outside your cluster, how they will be interacting with the microservices, because there are not many microservices, and if we talk about Netflix or Amazon or maybe Uber, there are thousands of services running behind, and And on the time, according to the progression of time, these services may increase or decrease. Maybe some services get more responsibility, then they are split it into maybe from one to two, and then it will be very difficult for the client to manage such things. So these scenarios are handled by external API patterns, and we will talk in detail about this pattern as well. Next is the security pattern. So security pattern is about managing the identity of the user from one service to the another service. Okay, and we use like access token pattern here. So that can be there. And next is cross-cutting concern pattern. So it talks about some concerns which are across the microservices. So I saw that there are a lot many developers have joined, and you must be using some property files to handle the configurations, right? But think of a scenario where your application is divided into maybe hundreds or thousands of services, and each service is deployed having instances from thousands to 10,000s. Then it will be very difficult for you to manage that property file. Let's say if you want to change any of the property, then it will be very difficult, right? So for this, this pattern helps us by externalizing those properties, and you can use some single configuration file mechanism wherein you need to change at single point, but that will be reflected in all the instances without making your system down at any point of time. Okay, so next is the observability pattern. So since your microservices are lot many in number, and it will be very difficult to monitor that using maybe you have heard about lot of tools, maybe ELK or something, but observing so many services, it's difficult because you need to make a track if your call is API call is made, and how it's traversing from one service to another. And if some of the service is slow, then you need to monitor which of your service is slow, because any of your service will make the complete API request slow, right? And of course, tracing the exceptions, tracing the errors. So it talks about that, and we use tools like Zipkin and Jagger, and they are based on open tracing. Okay, so it's more about that. And the last one, it's deployment patterns, wherein, of course, we have, okay, we have created our services, but how we will be deploying those services. So either we'll deploy on my bare metal machines, or we can deploy on virtual machines. And so nowadays, the trending pattern is service per container. So we containerize a service into Docker containers or maybe some other containers, and we deploy them. And there are some tools for orchestrating those containers. And the trending one is my Kubernetes, that is used in most of the companies, maybe in premises or on cloud. So it talks about more of deploying your microservices. So that was all about the patterns. And of course, today we will discuss in detail about external API pattern and service discovery pattern. Okay, before going to this, let's quickly see. Let's quickly go on Menti, and let's have a quiz tab. So maybe there must be some people who joined us late. They can go to menti.com and use this code 1775882 to connect here. Okay, so now look into your Menti screen, and the next question will be there. Please answer fast to score more points. Which of the following is not a microservice pattern? Creational pattern, cross-cutting concern pattern, observability pattern, and resiliency pattern. Wow. So most of you are correct. It's the creational pattern, which is not part of microservices pattern. And the people who have marked cross-cutting concern pattern. So we do have a cross-cutting concern pattern where we talked about externalizing the properties so that we do not need to change it in each and every service and each and every instance. And the resiliency pattern is more about making your system stable to prevent it from the cascade failure. Okay, so the correct answer is creational pattern. Okay, guys. So let's continue on the presentation. Don't close the Menti. We'll come back again here. Okay, so let's talk about some of the challenges. Already, I have described some of the challenges. Okay, so let's say there are some clients who want to interact with your services. Okay, and for this example, there let's say there is order service and billing service. Order service is exposed over REST, and billing service is exposed over gRPC. Okay, so let's take a scenario. Let's say order service got split up into delivery service, and so the new service is created, but let's say there are applications like native application who want to use this service, so they will definitely have to add a new endpoint to access these services, and this is same for all of the consumers, of course. So it's just an example that we are using from native application, but it's same for all. Okay. There can be a next challenge, like since we can see there is one service exposed over gRPC, and of course the web browsers do not support this protocol by default, and it's very difficult to manage those services which are exposed over gRPC to be handled by web browsers. And let's say there are third-party applications. They want to make a query which needs all the data from auto service, billing service, and delivery service. And if we talk about network, of course, the network behind your firewall, that means in the cluster, is comparatively very fast than the network outside your firewall. So that means the call from the third party consumer till your firewall will be very slow. And of course, the calls behind this can be fast. So let's say how this interaction will happen. First call will go to the firewall, which is slow, and the response will come back that will fetch some data from order service. And based on that data, two more calls will be created, the billing service and delivery service. And you can see three calls were made to get this data, and all the aggregation was managed by third party consumers, and this reduces the customer's experience and also slows down your actual response time. So these are some of the challenges which are possible when you split your services into microservices, but it can be solved by API gateway. So we in place the API gateway, and let's see how those same challenges are getting solved using this API gateway. So let's say a new service uh, is developed, okay, or maybe split it from order service or any existing service. So the endpoint for native application will remain the API gateway. So that will make a call to API gateway, and further that API gateway will make a call to delivery service. So there is no extra burden to be taken care to add a lot of endpoints if they are getting splitted, services are getting splitted. And let's talk about the gRPC one. So a web browser will make a simple HTTP call to API gateway, and further that API gateway will make a gRPC call to the billing service, and some protocol translation will be happening at API gateway, and the response will be returned as a simple REST call to the browser. For third-party scenario, a single request will be going to API gateway, and all further communications will be made by API gateway to all the services. It will uh, aggregate your data and send it back to the third-party consumer. And it can also do some more functionalities like authentication and rate limiting. So let's talk about those in detail. Okay. So API gateway. So to describe API gateway, I'll use analogy. So let's say if you go to some company and first you go to a reception, because definitely you don't know what all departments are located at what point, at what location. So you ask the reception where you need to go, and they redirect you to the concerned department. And let's say if they want to check your identity, they ask for some documents or maybe some identity proof, and then they allow you to go to the department. So similarly, API gateway is the first point of entry, where that will redirect or reroute you to the target service. It can also check some authentication itself. So yeah, first part we talked about request routing. So it will redirect your request to the concerned or the target service. You can do API composition as well, because for the third case we saw the lot of requests were made by API gateway, and it aggregated the data and sent it to the third party client. It did the protocol translation as well, because the services which were exposed over gRPC, they were automatically uh, the protocol translation was done.
Hello.
Uh, Hello. Yes, Ranjan.
Yes, sir. Yes, sir. I have one question. Actually, how can we implement it in our program? Uh,
Okay. Yeah, sure. Sure, Ranjan. So after just this after slide, we'll see how we can do in our code.
okay, sir. Okay, sir. Thank you.
Okay. Yeah, thanks. Okay. And as we talked about, so maybe Ranjan, till the time you can mute. Oh, thank you. Thank you very much. It can also, the API gateway can also perform these edge functions which we talked about, like authentication and rate limiting. Rate limiting means, let's say you may have a scenario wherein you have some gold customers or platinum customers, and wherein you allow platinum customers to have maybe 100 requests per second, while gold customer can only make maybe 70 or 50 requests per second, or maybe some free customers who can only make 10 requests per second. So that you can do using the API gateway, because that is the first entry point where you can measure these things. You can also do some caching. Let's say you have some static responses which are answered by the target service, and then you can cache them, and you don't need to make a request to the actual service. You can simply use the cache and return the response from that. Okay, so as requested by Ranjan, we'll see how it works. Okay, so we'll see some of the things like we'll see Nginx working as a reverse proxy. We'll see Spring Cloud Gateway working as a API gateway, which will handle some request routing, rate limiting, and API composition. And at the last, we'll see traffic. Traffic is one of the API gateway, and also used as or termed as the ingress controller in Kubernetes. So we'll see this demo traffic in Kubernetes at the end, because that will require a lot of hardware resources, and we'll see this part at end. But the all the other things, Nginx and Spring Cloud, we'll see just now. Okay, so let's move to the demo. Okay, so There are two applications, sample applications I have created here. One is the order service, which is created in Java using Spring Boot. So it's a simple application wherein a controller is created, okay, and that exposes some dummy data. Okay, so just let me run this. Okay. So this is made on Spring Boot, and the dependency tool we are using Maven. So that's why I have given the Maven command to actually to run this application. So let's wait for this service to run, and till the time we can make our other service, that is billing service. Okay, so this service, billing service, is created in Golang. And this is also a dummy service. Let's run using Go. And let me also run the Nginx. So Nginx is a highly used reverse proxy. So what we will be using Nginx as a reverse proxy. Okay, so I have already run that service, and let's also see the configuration used in Nginx. Okay, so let's check if all services are running. Yes, this is running on port number 8080. The billing service is also running on port number 8090. So let's check. Okay, so this is the dummy order service where we can see a list of orders, and let's say if we want to check any specific order, maybe order number 4. So we get some dummy data here. So for order ID 4, these are the few items. Maybe for order number, let's say, is 8. There are some other items here. And let's check billing service as well. Okay, so this is also running. As mentioned, this is running on port 8080, and this one is running on port 9080. And let's say we want to check some billing data for maybe order ID 4. So this is here. It's made on the credit card, and let's say we check order ID 8. So let's say its payment was done using Paytm. So these are the two different services running on the different ports. But we need to see a mechanism where there should be a single point which should redirect us to each and individual service, right? So we are using Nginx, and let's see what we did in Nginx. So it's a thing wherein we said, okay, if the request is coming with this URL order service, redirect it to this order service, which is located here 8080. Okay, and let's say if request is coming with the parameter billing service, then redirect it to this URL or this location on the localhost 9080. So let's see. So Nginx is running on port 80. Let me not type that. I already have the URL for that. Okay, so here you can see localhost, and by default it's port 80, so we do not need to mention that. And a slash order service slash orders redirects us to this service. Okay, and let's say we want to check same orders, order 4 or order 8, we get the same information. And let's say if we want to see the billing service, of course, localhost, this is the same endpoint. We are not using any other two endpoints for the same. And the request comes with this URL, it's redirect to the target service. The same here, we can check any of the service, I mean, and any of the billing, and it will be the same. Okay, so but of course, as I mentioned, Nginx is simply a reverse proxy, and it can handle only one scenario, that is rerouting your request, nothing else. There are some plugins available, of course, which can help you to make some of the things like authentication and all, but not more than that. So rest of the things we will see using the other example that which we said, like String Cloud Gateway. Okay, so let me close this Nginx. Okay, so once we close this Nginx, of course, this request will not be working. Okay, so let's move to another example wherein we'll see some more capabilities. Okay, so for that, I'll be using API gateway as String Cloud Gateway, and let me start it. And while the meantime, I'll also show you the configuration. Okay. So it is also a Spring Boot application, and the dependency tool is Maven. So we'll use the same command. Okay, and it will also require additional tooling called Redis, which is a key value database, and it has some functionality where you can use time to live kind of features, and after certain duration of time, the data automatically gets deleted. Okay, so I'll just simply turn on this Redis server. So this Redis server is up, and API gateway is getting up, and till the time it gets up, let's see the configuration. Okay, so similar kind of configuration is made here as well. So it says that if a request comes with this path, redirect it to this machine, this target, that is localhost 8080, and whenever the request comes with this URL, it will redirect it to this target, that is localhost 9080. Okay, and here we'll see some extra things like rate limiting, which we talked about, and also the API composition. Okay, so let's see one by one. So it has a lot of capabilities which we can do. Okay, so let's go check. Yes, the machine is up, and this service is up at port 8111. Okay, so let's check. Let's close this. Okay, so for this API gateway, a single point of entry is this localhost colon 8111, which is the port where this API gateway is running, and the functionality remains same. You can query orders or a specific order, maybe order ID 3 or maybe order ID 8, anything. And similarly, for billing as well, we are requesting on the same port, which is localhost 8111. And again, the behavior is still same, which was like we saw in Nginx. Then we can see some billings for particular order IDs, dummy order IDs. Okay. And now let's see the one example wherein, let's say, we want to fetch the data from both the services. We want to check, let's say, order data and the billing data at the same point of time. So right now we are making two requests. So for order ID 8, this, and let's say for billing also, let's check order ID. So then we are making two requests, and as we talked about, API gateway can do API composition as well. So there is already that API composition has been done, and let's say for order ID 8, it will aggregate your data, and it will be a single from client as we are making a single request. But yeah, in turn, behind the scenes, API gateway is making both these calls and merging your data, aggregating your data, and giving you the response back. So this is getting done by the API gateway. Okay, let's see the rate limiting as well. So I'll use a tool called Fiddler. Okay, you can use any other tool as well, but for the moment I'll be using Fiddler, and Fiddler is the tool mostly used for intercepting your request and response. Okay, so let's see. And if we check our configuration, so what we say in the configuration is that only 3 requests per seconds are allowed. So let's check uh, if it is able to do that or not. And behind the scene, it is using Redis server to maintain this rate limiting functionality. So that's why we turn on the Redis server. Okay. So let me hit this request billing service. Let me check. I must be having a billing request here, and this is the request. Okay. So I'll simply multiply this request by 10 times. So that means 10 requests will be going at the same moment. Okay. And let's see. These are the 10 requests.
Joining actually he got disconnected to the info, so he messaged me to joining. Right. So please wait for a minute. Be join.
Okay, sorry guys. I guess there was some network issue. I hope you can listen me now and see my screen as well.
Yes, yes.
Okay, thank you. Thank you very much. Okay, so let's continue. I guess I was lost at this point of time where I was trying to show the rate limiting feature.
Excuse me, Saurabh.
Yeah, hi. Yes, Piyush.
Yeah, hi. Actually, screen is not visible. So could you please check this at your end?
Sure, sure. Let me check.
We can see it now.
Okay, thank you. Okay. Okay, so there is one question from Vinayak, and he's asking how composition is taking place. Okay, so I'll move to that and I'll explain. So you need to write some code at API gateway if there is some feature about API composition, and you can make your own controllers here, which will call the APIs behind the scene and aggregate your data and give the response back. So I'll show you a sample here. So it's a simple order controller and which takes up your request and simply it calls your APIs behind the scene and aggregate your data. Although this situation here is I'm calling a hard-coded URL, that should not be the case. But this is for just for the example that you can aggregate the data here. I hope I answered your question, Vinayak. Okay. Okay, so of course the demo is done. Okay, you're welcome, Vinayak. So let's move to the Menti part. Let's please open your screen and let's see Menti, and then we will move forward.
So
I'm really sorry again, some network issue was there. Please let me know once you are able to see the screen.
we
Yep.
Okay, thank you very much. So now just look into your Menti screen and we are moving to the next question now. Okay, answer fast to score more points. And what can be done by API gateway? And the options are request routing, protocol translation, API composition, and all of the above. Okay, so yes, most of you are correct, and answer is all of the above because we can do all the things. And the people who have marked request routing and API composition, you are not wrong, but it also includes protocol translation. So the correct answer is all of the above. Okay, let's see the score. Swati answered wrong, I guess. So again, Piyush is the fastest one. Congratulations, and Arvin on second and Vivek on third. Okay, let's go to the next question now. Which of the following is not covered in API Gateway demo? Request routing, authentication, rate limiting, or API composition? Yes, most of you are already correct. Authentication was not covered in this API Gateway demo. And people who have said rate limiting, might be you missed it because of network glitch, but we covered the rate limiting part using Fiddler, wherein 7 requests were rejected and only 3 requests were passed because we set our 3 requests per second as the filter criteria. Okay, so let's see the results. Again, Piyush is the fastest one. Congratulations. And Arben, I hope I'm pronouncing the correct name, is remains on the second position and Vivek on the third. Okay, we'll come back to the mentee again. Congratulations till now to the top scorers. And let's see the remaining part of the agenda. Okay, so we covered this demo. Of course, the traffic in K8 as we'll see at the last. Now let's talk about the design itself. So of course, this is the first entry point and we need to be very careful because about performance and scalability. We should have multiple instances of API gateway so that it does not turn into a single point of failure. And if you are writing your code like API composition or something, then there are two approaches, of course, synchronous and asynchronous approaches, but both have some advantage and disadvantage. So synchronous approach is easy programming model and it's easy to write the programs, but it's limited by the number of threads the hardware have. So you should go on to asynchronous programming model, but it's quite complex because a lot of callbacks are used and you can be stuck into a callback as hell as well. So answer to that is you use the reactive way, wherein you can use something like a completable future in Java 8, or you can use some monos and flux in React project, or if you're going with some third party things like Rx Java or something, so you can use observables there. The next important thing is handling the partial failures. Yes, because some of your services at any point of time may be unavailable or slow. So you need to handle some partial failures and you should not fail the complete request. You should return with at least the data or the response you have from other services. So this you need to take care while designing or writing code in your API gateway. Okay, so next is the service discovery. So let me check the chat box if I have any question there. Uh, Vivek, I want to talk to you after this session. Okay, it's I guess some personal chat. Okay, so there's no question, but I was expecting a question here that how API gateway will handle this network, I mean the services which are again coming up or going down, because we talked about the scalability, means the scaling up or scaling down the solution according to the need. So maybe there at some point of time there is a huge traffic coming onto your application and you need to scale up your some of your services, and definitely those location of your services should be present with API gateway to route your request to the to the target services, right? Because for our example we hard coded that, but that should not be the scenario. That was just for an example, but for real cases we should use this with service discovery, because service discovery is a mechanism which helps us to discover the location of your services at runtime, which are maybe coming up, or even if some services are going down, then you should be aware about those, that the some service instance is lost and you should not redirect your request there. Okay, so this service discovery is done in two ways: application level service discovery and platform provided service discovery. And these uses two patterns in itself, like self-registration pattern and client-side discovery pattern is used in application level service discovery, and third-party registration and service server-side discovery pattern is used in platform-provided discovery. So let's look into these both the things in detail. Okay, so for application level service discovery, so service registry is the core component for any service discovery, and it is nothing but a database maintaining the service name with the exact location of your service, maybe or the number of instances it has. So let's take an example where you want to interact with order service, and any one of your instance is getting deployed. It got some IP assigned to it along with the port, of course, where you are deploying. So it will make a call to your registration API, wherein we talked about self-registration pattern. So it itself will make a call to registration API and provide its location there along with its name. And you can see here, it also contains a service discovery library, which is a client uh, which will interact with this service or discovery or the service registry. So it's a limitation, or I would say it's needed here, that you need to have some client library which will interact with the service registry. So similarly, let's say more instances are coming, they will register themselves. Uh, and so the service registry is ready with the live data of the target location, where exactly they are located. So let's say whenever the client will make a call, it wants to make a call to any of the service, and the client can be a API gateway also, because API gateway also makes a call to your target service, right? So that should also contain that library in itself. Okay, so it will make a call to query API, which will return the data, means all the location of the target service. And using any of the target location, it will make a call and get the response back. This is how the complete uh, request and response routing is done using application level service discovery. Let's say if any of the instance goes down, again, it will make a call to the registration API, and it will tell that, okay, it's going down, and so that that is deleted from the service registry. Coming back to the platform provided service discovery, again, the core component will still remain, that is service registry, but with two extra components called router and registrar. So these all things are part of your platform where you are actually deploying your service. It can be Kubernetes, it can be Docker Swarm, it can be OpenShift, it can be any platform which provides such kind of service discovery. So again, let's take an example where we are trying to deploy order service, and whenever the instance is coming, registrar is keep on observing the cluster. Okay. So once any of the instance is coming, it updates the service registry with the target location, and that means IP and the port. Of course, the port is not mentioned here, but it will also include port. So similarly, all the instances are updated, and whenever a client will make a call, it can be any other client, any other service, or your API gateway that will make a call to the router. Router will query the exact location, and it will redirect your request to the target instance, and it will return the response back to the service. Okay. So this is about platform provided service discovery, and of course, whenever an instance goes down, registrar is always observing the cluster, and it updates the service registry that some of the instance is going down. Okay, so let's see the demo, and but before the demo, I would say that out of these two, the recommended one is the platform provided service discovery. Until and unless you have a specific need, uh, which we'll talk about in maybe next after this demo. But the recommended way is platform provided service discovery. Okay, so let's see what we'll be seeing in the demo. Okay, so we'll see the application level service discovery, that is Eureka, using Spring Cloud Gateway, and we will try to register both the applications, that was order service built in Spring Boot application and billing service built in Golang application. Okay, and at the last we'll see the Kubernetes as well, which will also cover API gateway. Okay, so let me start the discovery service first, which is Eureka. This is also a Spring Boot application. So till the time it is getting up, let me add that client which we talked about. So let me check out the another commit. Okay, so there's a question from Aman. Can you please tell how the load balancing is going to be done? Maybe multiple clients request routing. Okay, so the load balancing here in the application level service discovery is handled by the client load balancer. Okay, so there is called ribbon, which helps you to balance your request across the multiple targets. And for platform provided service discovery, the load balancing is done by the router. Okay, I hope I answered your question, Aman. Okay, so order service, I have checked it out. Okay. Okay, so let me restart this. Okay, and also I'll check out the gateway part as well. And till the time it starts, we'll see the configuration changes. Okay. Okay. So, okay, it has reflected all the changes here which are made in configuration. We'll talk about that. And till the time, let's see if our Eureka service is up or not. Okay, so our Eureka service is up. And you can see when we started our applications order service and billing service, they are already discovered by Eureka. And API gateway is also getting started, and I hope once it will start, it will also discover the API gateway. So till the time it's discovered, let's talk about the configuration here. So now the change you can see is earlier we mentioned the exact location of the services, which was along with the port and localhost, which was 8080, and for this case it was 9080. But now it's not the case. We have just listed down the name of the service, and which is same as the service name which is discovered by the Eureka or the service discovery. Now all the information is having this service discovery is having that where exactly my service is. And let's say if we have more number of instances deployed, so the question as asked by Aman, those load balancing thing will be handled in this scenario. It will be handled by the caller, but for the platform provided thing, it will be handled by the router. Okay, so let's see if our gateway is up or not. Yeah, it's up. So let's refresh it, and you can see this is discovered by our uh, service discovery. Okay, so let's check the same behavior if we can see or not. So again, we'll go to the same links, which is this. Nothing is changed, and you can expect the same output, although it's in JSON, I guess. But oh, sorry, it's XML, but it's response is same. I'll simply call this using a REST client. Okay, so you can see here it's a JSON now. And similarly, for the billing as well, you'll get the same response. But the change is only that we have removed the hard coding of the service targets from the configuration, and it's now getting discovered automatically by the discovery server. Okay, so this was about the discovery service, and if I talk about the some of the changes, so you can see here the order service is built in Spring Boot. So the differences here you can easily see that some library is getting added. So it's this library that is Spring Cloud Starter Netflix Eureka client is added, and only minor changes you need to do, that you need to enable this Eureka client. That's all. But this same thing is not present with Golang, if we talk about, because that is entirely a different language. And so I had to write my own code uh, for that to register this in service discovery. So you can see here there is one method called register, which is getting called when the application is initialized, and it makes a call and self-registers itself. So this is how this is being done. And let's see it live here. As of now, Eureka is discovering all. That's correct. So let's close this. I guess I closed the Eureka itself. Okay. Let me close this API gateway for the time being. Let me close order service also. Uh, there's a question from Piyush. We noticed that LB is in URL section of configuration. Could you make us clear? Okay, so this load balancing, as I mentioned, so this means that this is a load balancing request, and it needs to be taken care by the ribbon, which is a part of this a Spring Cloud Gateway. Yes, yes. This is how the Spring has made this configuration. So you need to mention this keyword. Yes. Okay. So here we can see only billing services up, and once I make this down, I will at the same time we'll see that billing service is no more available. So this is how the service discovery is working. So let's close it and let's quickly finish the remaining stuff. I'll not take much time now. Okay. Okay. So as I said about service discovery, uh, there is a specific requirement of framework for application level service discovery. That means there is some dependency on its language specific framework, but there is also use case wherein you should go with this application level service discovery, wherein you need to deploy your application on hybrid platform. Let's say maybe having some platform already having some service discovery mechanism, or maybe there is another platform which does not have any such kind of mechanism. You are on uh, legacy systems like bare metal machines or VMs. So in that case, you should go with the application level service discovery. And for platform provided service discovery, of course, it does not need any additional framework, and so it's language agnostic. And but the limitation it only supports a specific platform. So but nowadays, yeah, people are moving to single platform. I mean, it can be distributed in nature, but it's single. People are moving towards Kubernetes or OpenShift. So the recommendation is, if you're going with such kind of platforms, use platform provided service discovery. Else, only for few cases you should go with application level service discovery. So yeah, that was about the session today. And before closing it or before question answer, let's finish our quiz. Okay, so look into your Menti now. Which of the service discovery pattern is recommended? Application level service discovery, platform provided service discovery, or it is not required because this is waste of time? So everyone is correct. The recommended one is platform provided service discovery. So let's see the leaderboard. Okay, so Piyush is still the fastest one, and the Urban is on second position, and Aman Sharma is on third position. So I guess Vivek lost his position. Okay, so the last question: be quick, be correct to score more. Uh-uh. Which is the correct option? Order service was developed in Java, billing service in Java, order service in Go, billing service in Go, order service in Java, billing service in Go, or order service in Go and billing service in Java. Okay, so this was simply a tricky question. If you heard correctly, I described where billing service was built in Go, where we wrote the custom code, and order service was written in Java Spring Boot, wherein we simply added the dependency using Maven. Okay, so let's see the leaderboard. Okay, so Piyush is the fastest one, and congratulations, Piyush, and congratulations, Urban, as well. And the third name I cannot see right now, but congratulations. So there was a surprise gift as well. I mean, so you can visit the site www.enigmacode.dev, and you can avail 30% discount. So Piyush can avail 30% discount on microservices course, and Arvin can get 20% discount. And the third one, Swati. Swati can get 10% discount on the same microservices course. So that's what's about the
Thank you,
quiz.
sir. Thank you so much.
You're welcome, Piyush. So if you have any questions, please ask. Leave your feedback here using Menti or on chat. And till the time, of course, the time is already over. If you are interested, I can also demo the Kubernetes part. So feel free to ask your questions or provide your feedback. What you liked, what you disliked, what can be improved. Everything is welcome. So till the time, I will start the mini queue. And thank you for the participation. And of course, you can connect us at enigmacode.dev. You can connect us on email also. That is enigmacode.info@gmail.com. You can connect on LinkedIn. You can join the Facebook page, that is enigmacode.dev. And you can join Instagram page as well for upcoming webinars, for some discounts on the courses. So you can connect anytime. Happy coding. And guys who are interested, please stay connected. I can show you the Minikube demo as well. There is a question from Arvind. Though I don't know Java, still this was totally understandable session. I got idea on the. Okay, thank you, thank you. So till the time I can talk about Minikube. Minikube is the single cluster Kubernetes. You can run this on your local laptop as well. And but limitation is that you will only get a single node, and but you can experience all the interactions just same as the Kubernetes. Only scaling up the node or joining a new node is not possible, but in as a developer you can perform all the activities here, from deploying your pods to scale your pods, creating your services, creating ingress controllers, everything you can do in Minikube. There are other options available. You can use micro K8 as well. So, but for as of now, I am using Minikube. So I saw that there was a few of you had some experience about the containerization as well. So I have already containerized these applications so into Docker containers, and the images are already pushed. And I have created some configurations files as well to deploy things on Docker, sorry, Kubernetes. You can see these configurations. It will create a deployment of billing. It will create a service as well. You can see that replica is 2, and that means 2 instances of this billing service will be running. And there's a traffic ingress controller will be used as an API gateway. It's a very resource consuming process, and it's take a bit time to start. Okay, so we are done. We are good to go. So let's see quickly. So this is the UI of API gateway, which we talked about, that is traffic. I guess the pod is getting up. Minikube is recently started, and okay, so things are up. I guess it should work now. Okay, so yeah, this is working. So let's check order service and billing service as well in Minikube. So we can see, okay, order service is still getting started, but the billing service is already up, and we can see the results here, same as the previous one, and we are using here traffic as a API gateway, which is called ingress controller in Kubernetes. So feel free to connect with us to get more to know more about Kubernetes or microservices, and we will notify you once we'll plan next webinar on the other topics. Thank you very much. Thanks for your time. Thank you for joining.
Thank you so much, sir.
Okay, you're welcome, Piyush. Okay, so
I guess someone was asking something. So, is there anyone?
uh, I think Ranjan Das wanted to connect with Vivek. If he's there, please connect with him.
Okay, I guess he has left. So, Vivek, you can connect him in person on any social media or LinkedIn.
Okay. Okay, guys. So bye bye. Good night. Happy coding, and keep on learning and stay safe. Be at home. Bye bye.
Good night.